Imagine a city built in the middle of the desert, stretching 170 kilometers and standing 500 meters tall. This isn't a figment of imagination, but an actual project under development in Saudi Arabia. This is Neom, a $500 billion city in Saudi Arabia, planned to be constructed with 2 super towers that are as ambitious as they are unique. However, this futuristic dream is encountering hurdles so massive that everyone is questioning whether it will ever be completed. Let's examine what is going wrong with this grand vision. The most obvious issue is money. Initially, the line was projected to cost $500 billion. However, the current estimate has skyrocketed to about $1.5 trillion, an increase of nearly 3 times. It's like planning to purchase a Ferrari but discovering you need to buy a fleet of spaceships instead. These massive cost overruns have necessitated a drastic reduction in the scale of the first stage of construction. Originally, the line was supposed to span 170 kilometers, but it has now been shrunk to a mere 2.4 kilometers. To illustrate, it's like shooting for the moon but ending up in someone's backyard instead. But this is not the only problem. Let's discuss the city's architectural concept. Neom, or Neom, is designed not to expand horizontally but vertically, akin to a giant beanstalk. The concept is both innovative and creative. Residential buildings, workplaces, educational facilities, parks, and other amenities typical of a modern city are stacked vertically within 2 skyscrapers. The goal is to maximize usable space without harming the natural environment of the desert. In theory, this is the most efficient way to counteract urban sprawl and environmental degradation. However, turning this complex idea into reality presents significant challenges. Of course, there's the foundation, an engineering marvel in itself. Unlike traditional city foundations, which are built to accommodate shorter, spaced-out buildings, the line's foundation must extend for kilometers to support enormous towering structures, resembling a continuous skyscraper. Structural engineers are using piles, which are like strong cylinders driven into the ground. Some of these piles have been pushed up to 200 feet below the surface to provide a firm base on the bedrock layer. It's like trying to organize the tallest building made of Jenga blocks in the world, and this is just for the first 2.4 kilometers. The complications will only increase as they attempt to extend it further. Every pile must be precisely placed and fixed to ensure the stability of the entire structure. There is nothing quite like this in terms of planning and implementation, and the pressure is immense. The foundation must bear a weight equivalent to 60 Empire State Buildings placed side by side. Moreover, environmental stresses such as wind loads, earthquake loads, and the weight of the occupants and structures must be managed. These forces need to be sustained long-term, necessitating the use of high-strength concrete and specific types of steel in building these piles. The stage of construction is crucial given the scale and complexity of the work required to ensure the solidity and durability of such an unprecedented structure. Now, let's consider the outer shell of the line. The building's most striking feature is its shimmering glass facade. This is not just a design choice, but a means of controlling temperature by reflecting sunlight. However, acquiring and applying enough glass to cover 2 giant skyscrapers is no easy task. The sheer scale of the aluminum and copper required could drive up prices and lead to supply chain issues. Additionally, the installation must be executed with precision to meet both structural and aesthetic requirements. It's a shiny problem just waiting to happen. Inside the line, things get even more interesting. Unlike common high-rises where floor layouts are generally standard, the line is intended to be divided into different modules, each with a completely unique layout and purpose. These modules are designed to fragment the vertical city into various areas and services for the residents. However, this introduces another layer of architectural and engineering complexity. Coordinating these modules to ensure they fit together well and maintain structural integrity will be a significant challenge. Imagine a game of Tetris where the blocks are neighborhoods, but on a much larger scale. And if one piece doesn't fit, it's not simply game over, it's an architectural disaster, the likes of which the world has never seen. Transportation within the line also presents a challenge. Unlike a horizontal city, which depends on roads and avenues, the line relies heavily on a single high-speed rail that will handle most of the horizontal movement from one end to the other. This is crucial because without such a facility, commuting would be a nightmare. Residents would have to travel to one end of the city only to retrace their steps. Along with vertical elevators and escalators, this rail system will form the core of internal commuting within the city. However, the challenge lies in connecting these systems within the vertical structures without losing significant space and suffocating the city. It's like solving a jigsaw puzzle where every piece must fit perfectly to ensure the functionality of the entire system. No small feat. Sustainability is one of the pillars on which the future of Neom is being built. The city is envisioned to be 100% reliant on renewable energy, powered by huge solar and wind farms in the surrounding desert. Additionally, Neom will include water desalination plants to supply fresh water, with technology that guarantees both efficiency and sustainability. This is a vision of what a technologically advanced, sustainable city of the future might look like anywhere in the world. However, integrating all of these systems into the existing framework of the city is no easy task. Each component must work toward the project's various environmental management goals, and any missteps could lead to a crisis. One of the most pressing logistical issues Neom must solve is how to house and feed the vast number of construction workers. Developing this mega project requires accommodating thousands of workers in the middle of the desert. Temporary worker cities have been established, equipped with facilities such as schools, medical centers, and playing fields. These are intended to be comfortable homes for the workers, but they must also be adaptable to changes in the workforce needs as construction progresses. Another significant challenge to Neom's progress is environmental issues. While the reflective glass used in the building's facade is both functional and visually striking, it poses a danger to migrating birds. The project's planners are aware of this problem and are considering actions to reduce the risk, including the use of bird-safe glass and other methods to deter birds from approaching the building. Additionally, the large-scale construction and resource consumption have sparked controversy over the project's environmental impact. As time passes, people around the world view Neom's construction with both wonder and skepticism. Neom is undeniably futuristic, but it proposes ideas that are still unimaginable in today's urban development landscape. In fact, we don't even have prototypes for much of the new technology required to complete the project. The engineering and technical challenges are immense, meaning the only way the project can succeed is by overcoming these obstacles while staying true to its vision. Can Neom become a global role model and a symbol of the future, characterized by technological and environmental excellence? Only time will tell.